Pure Mathematics, Paper 2, Wednesday, 12 June 2019. Answer all questions and ensure that your answers to parts of questions are clearly labeled. You should show sufficient working to make your methods clear. Answers without working may not gain full credit. Given that 2 to the power x times 4 to the power y is equals to 1 over 2 over 2, express y as a function of x. To express y as a function of x, we can write all of them to the base 2. So 2 to the x stays as 2 to the x. 4 is the same as 2 squared, which is, so this would be 2 to the power 2y. 1 over 2 half is the same as 1 over 2 half is the same as 2 to the minus 1. And 1 over square root of 2 is the same as 2 to the power minus a half. Because square root of 2 is equal to 2 to the power half. And when you take it to the numerator, it becomes 2 to the minus a half. Now that the base is the same, 2, 2, 2, 2, we can add their powers. So 2 to the x plus 2y, and minus 1 plus minus a half is minus 3 over 2. So the base is the same, the powers have to be the same. So x plus 2y has to be equals to minus 3 over 2. Now we solve for x. Plus 2y plus x is equals to minus 3 over 2. So we want to make y the subject. So we'll take plus x to the right, it becomes minus x. And it's times 2y. Opposite of times 2 is divided by 2. So we take it to the right, it becomes minus x divided by 2 and minus 3 over 2 divided by 2, which gives you minus 3 over 4. So your answer is y equals to minus x over 2 minus 3 over 4. So y is now the subject of that equation. The speed of a small jet aircraft was measured every 5 seconds, starting from the time it turned into a runway until the time when it left the ground. The results are given in the table below with the time in seconds and the speed in meters per second. So we have time in seconds and speed in meters per second. Using all this information, estimate the length of runway used by the jet to take off. The first thing we want to do, we want to plot those information on a graph. So we have the speed in meters per second on the y-axis, the time in seconds on the x-axis. So it goes from 5 meters per second up to 45 meters per second. And the time goes from 0 up to 30 seconds. So we have 0, 2, we mark that first point. 5, 5, we mark that point. 10, 10, we mark that point. 15, and we mark that point. With the one with 20, we mark all the points and join it with a curve. Now, we want to estimate the area under. So you imagine this area under that shape there. We want to find the area I have shaded. So we can approximate it to be a trapezium. So this little corner there is this one here. This long side is this one, which is 42. So this is 2. This long one there is 42. And we know this one is 25. So we can use the formula for a trapezium. And the top of hand, on the top on the right hand side, got the formula for a trapezium. Area is half a plus b, half a plus b times the height in between them. So that's what we're going to use to estimate the area. And that area will represent the distance. So the area under the speed time graph represents the distance. So it's half times 2 times 42 times the distance between them, which is 25. And that gives you 550 meters. That's the distance. Another way to do it, you can use the Sievert equation. So S is equals to UT plus half AT squared. The final speed is 42. Initial speed is 2. The time is 25 seconds. And the acceleration, we get the acceleration using V equals to U plus AT. 42 is the final speed. Is equals to initial speed is 2. Is equals to A times T. So acceleration is change in velocity over time. That's V minus U divided by T. And that gives you 1.6 meters per second squared, which is A. Now you substitute those in. So your U is 2. So 2 goes there. T is 25 plus half. A is 1.6 times T squared. And that gives you 550 meters as well. Question 2b. Given that the jet accelerated smoothly in these 25 seconds, explain whether your answer to part A is an underestimate or overestimate of the length of the runway used by the jet to take off. If you look at this diagram, we had to find the area of a trapezium, which is this area. So we had to find more. This yellow one is the excess. So we had to find an extra. The yellow one is the extra. So it is an overestimate, because when we draw the trapezium, we didn't draw it underneath. We had the line over. So we had this yellow as the excess, which we had to calculate. There's the yellow there. So that means we had an overestimate. So we would say it's an overestimate because top of the trapezia lie above the curve. So that's the curve, and the top of the trapezia lie above it. Or the area of the trapezia is greater than the area under the curve. So you can have any diagram which gives reference to the extra area, which I showed you in yellow. Or you can say the curve is convex. So those are the things you can say to show that it's an overestimate. So that's question 2. And that's the answer to question 2. Question number 3. Figure 1 shows a sector AOB of a circle with center O and radius 5 centimeters and angle AOB is 40 degrees. The attempt of a student to find the area of the sector is shown below. Explain the error made by this student and write out the correct solution. The student should have worked in radians. The student is using degrees, 40 degrees, but they should have used radians. Or you can say the student did not convert degrees to radians. Or 40 should be in radians. Or the angle should be in radians. That's a different way to say the same thing. Now you can use the formula. The angle should be, the formula is angle over 360 times pi radius squared. That's the formula you should use for finding the answer. So the student should have used radians. And this is the correct solution for 3b. Angle divided by 360 times pi r squared. That gives you area of the sector. The angle is 40 divided by 360 times radius is 5 squared times pi. That gives you 25 over 9 pi centimeters squared, which would give you 8.73 centimeters squared. That's question 3 and the answer to question 3a and the answer to question 3b. Question 4. The curve C1 with parametric equation x equals to 10 cos t, y equals to 4 root 2 sine t. Meet the circle C2 with equation x squared plus y squared equals to 66. Given that one of these points S lies in the fourth quadrant, find the Cartesian coordinate of S. So for question 4, we have C1, the first circle is given in parametric, and then the second circle is given in Cartesian. So now we want to solve it. We substitute, replace x squared with 10 cos t, replace y squared with 4 root 2 sine t. So 10 cos t all squared, it becomes 100 cos squared t. 4 root 2 sine t squared, it becomes 32 sine squared t is equals to 66. We replace cos squared t with 1 minus sine squared t. So, and then after that, we remove bracket. 100 times 1, it gives you 100. 100 times sine squared t is minus 100 sine squared t plus 32 sine squared t is equals to 66. We would add minus 100 sine squared t plus 32 sine squared t. And we would take 100 to plus 100 to the right hand side. It becomes minus 100. So we have minus 100 plus 32. It gives you minus 68 sine squared t equals to 66 minus 100. And then, so sine squared t now would be minus 34 over minus 68. Sine squared t would be a half. So sine t would be square root of a half. Square root of a half is plus root 2 over 2 or minus root 2 over 2. But we know that cos squared t is equals to 1 minus sine squared t. But sine squared t is a half. So we have 1 minus a half. It gives you a half. So cos squared t is equals to a half. And cos t is square root of a half, which is plus root 2 over 2 or minus root 2 over 2. So what we want to do now is we have x equals to 10 cos t. We want to replace cos t. So 10 times root 2 over 2, which gives you 5 root 2. Y is equals to 4 root 2 sine t. We want to replace sine t, which we would replace it with root 2 over 2, and that will give us 4. We do it again with the next pair of coordinate. X equals to 10 cos t. We replace cos t. It gives you 5 root 2. And we replace sine t minus root 2 over 2. It gives you minus 4. So because it is x is positive, because x is positive and y is negative, so it is inside this quadrant, the fourth quadrant, because you go positive for x and negative for y. So you go positive for x, negative for y. So it's in the fourth quadrant. So which one will be in the fourth quadrant? The 5 root 2 is the positive going that way, and the minus 4 coming down. So that's 5 root 2 and the minus 4. So that means x is 5 root 2, which is 7.07, and y is minus 4. So that's question 4. The first part of question 4 and the final part of question 4. Question number 5. Figure 3 shows a sketch of the curve with equation y equals the square root of x. The point PXY lies on the curve. The rectangle shown shaded in figure 3 has height y and width delta x. Calculate the limit at square root of x delta x. So it is very important to know what this sign means. That sign means sum. It means you add all from 4 up to 9. So you start at 4 and you end at 9. So it means sum. Now, but because we are summing very small changes, delta x means very small changes. And when these changes are very small, what you're doing is integrating. So when it is delta x, for small changes, you integrate. So it wants us to integrate from 4 up to 9 because the limit is delta x tends to 0. The gap, the difference, the size of it tends to very thin slices. And it goes to very thin slices, you integrate. So you integrate square root of x. You can write square root of x as x to the half from 4 to 9. So x to the half, you add 1, it becomes 3 over 2. And you divide by 3 over 2, it becomes 2 over 3. So you substitute 9 and you substitute 4. When you substitute 9, and then you substitute 9 first, and then you substitute 4, and you subtract them. When you substitute 9, you get 54 over 3. And when you substitute 4, you get 16 over 3. When you subtract them, it gives you 38 over 3, which you can write as 12 and 2/3 or 12.7. And if you use the summing formula in your calculator, your graphics calculator, from 4 up to 9, square root of x, you get 15.15973. But when you use integral from 4 to 9, square root of x dx, you get 12.7, which is that. So you can see that when you integrate, your answer is much more accurate than when you are summing them up because you are using bigger slices, but here you're doing very thin slices. So make sure you integrate it to show you're working. Don't just use this calculator to get the answer. And that's how you get your answer in the exams. That's question 5. That's your complete answer for question number 5. That's question number 6. Figure 4 shows a sketch of the graph of y equals to g of x, where g of x is equals to that function. Find the value of g of 0, and find all the values of x for which g of x is greater than 28. So we want to find g of 0. So let's use the part on the right in front. Let's do g of 0 first. So we want to find g of 0 first. So we substitute 0. So we put 0 there. So that would be 0 minus 2 squared plus 1, which will give you 5. Now we've got 5. We now use that 5 now and substitute now into g. So g of 5. So it would be 4 times 5 minus 7. That gives you 13. So g of 0 is equals to 13. And one thing to remember is we have here when x is less than or equals to 2. When x is less than or equals to 2, we are using this function. So that is why when we have g of 0, we put it in this one because 0 is less than or equals to 2. Now when we get 5, 5 is bigger than or equals to, bigger than 2, so we put it in this one here. 4 or 5 minus 4 times 5 minus 7. Find all the values of x for which g of x is bigger than 28. So let's start to solve x minus 2 all squared plus 1 equals to 28. And we'll also solve 4x minus 7 equals to 28. So we'll take plus 1 to the right. It becomes minus 1. So 28 minus 1. We left with x minus 2 squared. We take the squared to the right. It becomes square root. So x minus 2 is equal to square root of 27. And we take the minus 2 to the right. It becomes plus 2. So x is 2 plus or minus square root of 27. And you put that in your calculator, it will be x equals to 2 plus or minus 3 root 3. Okay, let's go and solve 4x minus 7 equals to 28. Minus 7 goes to the right. It becomes plus 7. So 4x equals to 35. You divide by 4. 35 divided by 4. So that's what x is. So what you will find out is for g of x to be bigger than 28, x should be less than 2 minus 3 root 3, or x should be bigger than, and x should be greater than 35 over 4. Okay, I've done the graphs here. So the first one, x minus 2 squared plus 1 for x less than 2 is this blue part here. It comes there and it stops. And 4x minus 7 from 2 upwards is the red one. So x equals to 0, it says it crosses the y-axis at y equals to 0. That's how you can do the graphs on the calculator. Make sure you put that comma and that comma. That means it's less than 2. That means it's greater than 2. And 2 minus 3 root 3 is the same as minus 3.196, which if you look at the graph, if you come here, that's the point there, minus 3.196. So this one, so you want point where is 28. So if you have y is 28, that's 28 there. So y is 28. You want it to be bigger than 28. So you want the part which is below this side. That's why you have x is less than minus 2 minus 3 root 3. And so that's why when we put y equals to 28, it gives us that line. And y equals to 28 is that line. That line is y equals to 28. Now, 35 over 4 is 8.75, which is that 8.75 there. So it is this point here. So you want the side, this side, because when it is x is bigger than 8.75, you get that value is bigger than 28, because that point there is 28. So you want this side. So that's how we decided using these graphs. The function h is defined by h of x is x minus 2 squared plus 1 for x less than or equals to 2. Explain why h has an inverse but g does not. This is g of x and this is h of x. H is a one-to-one function or mapping, so it has an inverse. You just need to remember that one-to-one functions have an inverse, so you can go from 1 to the next, 1 to the next, 1 to the next, and you can go that way and come back. You can go forward and come back, forward and come back. But G is many to one. Many to one is like you have 1, 2, 3, all of them go just to 1. So that's many to 1. So it does not have an inverse. So G of x is a many to 1, so it does not have an inverse. H of x is a 1-to-1, and it has an inverse. So remember the difference. 1-to-1 is like that, 1-to-1. And you can come back the other way. Many to 1, like you can have 1, 2, 3, 4, 5, and there's 3 of them. That goes to 1. That's 1, 2, 3 goes to 1. So that's many to 1. And you cannot come back. You don't know where to come back to. So that's many to 1. Part D. Solve the equation h inverse of x equals to minus a half. One way you can do it, you can multiply this by h and multiply this by h. So it's like multiply by h on this side and multiply by h on that side. So h times h inverse would cancel to 0, will null each other, you'll be left with x. And then h bracket minus a half. H of minus a half means you substitute minus a half for h. So this is h of x. So wherever you see x, you put minus a half. So you put minus a half minus 2 all squared plus 1. And from there, you would see y equals to x minus 2 all squared plus 1. Or what you can do is replace h of x with y, and then you make x the subject. So you replace h of x with y, and then you make this x the subject. So plus 1 comes to this side, it becomes minus 1. The square comes to the right, it becomes square root. The minus 2 adds to it, so it becomes x is equals to 2 plus or minus square root of y minus 1. And now you can swap x and y. So now you have y equals to 2 plus or minus square root of x minus 1. And since y now is your h inverse of x, so that's your h inverse of x. Now you can substitute minus a half in there. So you have got 2 plus or minus square root of x minus 1 is equals to minus a half. Not substitute in there. Is equals to minus a half. So the 2 goes to the right. It becomes minus 2. So minus a half minus 2. And x minus 1, square root of x minus 1, minus a half minus 2 is minus 5 over 2. The square root goes to the right, it becomes squared. X minus 1 is equals to minus 5 over 2 squared. Minus 1 goes to the right, it becomes plus 1. So x is 29 over 4, which is 7.25. That's how you can find the inverse of h first, and then equate it to half and solve it. So what we did was we find h inverse and then make it equals to a half, equals to minus a half, and then we solve for x. So that's what we did. And if you notice, your answer of 7.25 there is the same like this 7.25 there. So this answer of 7.25 is the same like this answer of 7.25. It's the same. So this way is quicker. This way is longer. That's question 6. Question 6a and b. Part of question 6b. The graphs of question 6b from the graphics calculator, which is used to determine which part of it is bigger than 28. Question 6c and question 6d. Question number 7. A small factory makes bars of soap. On any day, the total cost of the factory to the factory y pound of making x bars of soap is modeled to be the sum of two separate elements, a fixed cost and the cost that is proportional to the number of bars of soap that are made that day. Write down the general equation linking y and x for this model. So let's y pound is the total cost of making x bars of soap. Bars of soap are sold for £2 each. So using equation of a straight line, y equals to mx plus c. Y is the total cost, m times the number of bars of soap plus a fixed cost. So in equation linking y and x, we can write y is equals to kx plus c, where k and c are constants. The bars of soap are sold for £2 each. On a day when 800 bars of soap are made and sold, the factory makes a profit of £500. On a day when 300 bars of soap are made and sold, the factory makes a loss of £80. Using the above information, show that y equals to 0.84x plus 428. So what we want to find is the total cost to produce is equal to the number of bars produced times the cost for 1 bar minus the profit. So we can say y equals to x, the number of bars, times £2 per bar minus the profit. So when x is 800, so we substitute 800 in there. So y is 2 times 800 minus the profit, which is 500. That profit there is 500. And we're making 800. So that will give you, when x is 800, you get 1,100. And then when x is 300, we will substitute 300 bars of soap, and it makes a loss of 80. So we add it. Remember, it's a plus now, not a minus. It's a plus because that was a loss. So that gives us 680. When x is 300, y is 680. So using that equation we had in the beginning, y is 1,100, x is 800, and we have k and we have c. For the next one, y is 680, x is 300, and we have k plus c. So that was 1,100, and that was 800. Now we can swap them around. Take all of this to the left side and take this to the right side. Take all of this to the left side and take this to the right side. So we would have it where we can have ax plus by is equals to c. So in your calculator, you go into the mode and choose solving simultaneous equations and choose 2 because there are 2 variables, k and c. So 800 goes for the first one, 1 goes for the second, and 1100 goes for the 300 goes next, 1 goes for this one, and 680 goes there. And when you press execute, you'll get 2 answers, 0.84 and 428. So that means your k, which represents your x, is 0.84, and your y is 4, your c is 428. So you can write the equation as y is equals to 0.84 x plus 428. QED, quod erat demonstratum, as required to show. Part C, with reference to the model, interpret the significance of the value 0.8 in the equation. 0.84 represents the cost of making 1 extra bar of soap in pounds. So the cost for making 1 extra bar of soap in pounds, or 84 pence for making 1 extra bar of soap. Assuming that each bar of soap is sold on the day it is made, find the least number of bars of soap that must be made on any given day for the factory to make a profit that day. So if you have n bars of soap, so 2n minus 48 plus 0.84n should be bigger than 0. So you remove the bracket. So 1.16n, 2n minus 0.84 is 1.16. 2 minus 0.84 is 1.16. 1.16n minus 428 is greater than 0. So you can divide by 1.16. So n is equals to 428 divided by 1.16, which will give you 369 bars of soap. Or we can say, let n be the least number of bars to make a profit. So 2n is equal to 0.84n plus 428. We want to solve it for n. So we'll take to the left-hand side. So it becomes minus 2 minus 0.84 is 1.16, n is equals to 428. Divide by 1.16, n is equals to 428 divided by 1.16. It gives you 368.9655. And you cannot have 0.9 of a bar of soap, so you got to make round to the 369 bars. That's question 7. Question 7a and part of B. That's the rest of question 7b and question 7c and question 7d. Question number 8. Find the value of the sum from r equals to 4 to infinity of that and show that this is equals to 2. So sum to infinity, we have the formula there which you get from the formula book, and the common ratio is a half. So think of it this way. We are starting from 4 and we want to go to infinity. So we start from 4 and we want to get to infinity. So we want to find from 1. We want to find from 1 to infinity first, because we start from 4 and we get to infinity. So we want to start from 1 to infinity and then minus from 1 to 4. So we get from 1 to infinity minus from 1 to 4. That will give us from 4 to infinity. That's the idea. So we want to get from r equals to 1 to infinity minus from 1 to 3. And that will give you from 4 to infinity. And this is the formula for sum to infinity. So when r is 1, we put 1 in there. We'll put 1 there. You get 10. When r is 2, we put 2 there. We'll put 2 there. We get 5. When r is 3, we say we'll put 3 there. Put 3 there. Get 2.5. And when r is 4, it gives you 1.25. So the first term a is 10. Common ratio is second divided by first. 5 divided by 10 is a half. Or you can do 2.5 divided by 5, which will still be a half. When we substitute the values, sum to infinity using this formula here. So a is 10. A goes there. And the 1 stays there. And the common ratio is a half, which is that. Minus sum from 1 to 3. We want to add 1, 2, 3. That's the sum from 1 to 3. Add these 3. So you add them together. That's the sum from 1 to 3. So that will give you 17.5. So be 20. When you work all of that, you get 20 minus 17.5 gives you 2.5. Question 8 part 2, we want to show that sum of that is equal to 2. So let's start with 1. Put n is 1, 1. So log of 1 plus 1 over 1 plus 1 gives you log of 3 over 2 to the base 5. When n is 2, we sub in 2 and sub in 2. 2 plus 2 is 4. 2 plus 1 is 3. When n is 3, we sub in 3. That gives you log of 5 over 4 to the base 5. When n is 4, it will be log of 4 plus 2 is 6 over 5 to the base 5. And we carry on until when we get to 47, 46. So n is 46. We put 46 plus 2 over 46 plus 1. It gives you 48 over 47. When n is 47, we get 47 plus 2 over 47 plus 1. It gives you 49 over 48. When n is the last term, which is 48, we have 48 plus 2 over 48 plus 1. 48 plus 2 is 50. 48 plus 1 is 49. So these are the terms when n is 1, n is 2, 3, 4, and then that's 46, 47, 48. Now this thing means sum, means we sum them, we add them up. So it means we add all of this, all of them up. So when we write to add them up, it will be log of 3 over 2 to the base 5 plus log of 4 over 3 to the base 5 plus log of 5 over 4 to the base 5. It carries on until we get to log of 49 over 48 to the base 5 plus the last one, log of 50 over 49 to the base 5. Now we see there's a log there, log in front of all of them. So we can take that log to the base 5 out of the bracket, because when you add logs, you multiply them. So we'll multiply 3 over 2 times 4 over 3 times 5 over 4 times so on, and times 49 over 48 and times 50 over 49. But if you, what you want to watch now is look at these numbers carefully. There's a 3 there and there's a 3 there. These 3 will cancel. The reason why I cross it out in yellow, it means they will cancel each other. There's a 4 there and the 4 there, that will cancel each other. And that means this 5 will cancel with a 5 down here somewhere. This 49 will cancel with this 49. This 48 will cancel with the 48 there somewhere. So what you're left with is 2 and 50. So you're left with this 2 and you're left with this 50. The others would cancel each other out. 50 divided by 2 is 25. So you can write it as log of 25 to the base 5. 25 is the same as 5 squared. So you write 5 squared, and the 2 power to the front, the 2 can come in front. So it becomes 2 log 5 to the base 5. Log of 5 to the base 5 is 1. So your answer is 2, which is what they wanted you to show. Quod erat demonstratum, as required to show. So that's question number 8. Question 8, part 1. Question 8, part 2. And the final part of question 8, part 2. Question number 9. A research engineer is testing the effectiveness of the braking system of a car when it is driven in wet conditions. The engineer measures and records the braking distance d meters when the brakes are applied from a speed of v kilometers per hour. So they've got the graphs there. Part A, explain how figure 6 would lead the engineer to believe that the braking distance should be modeled by the formula d is equals to kv to the power n, where k and n are constants and k is approximately 0.017. So the way you do it, you take logs on both sides. So if d is equals to k times v to the power n, then if we put log in front of d, log to the base 10 is equals to log to the base 10 of k plus, because when you take logs, you separate them and add them, plus, and the n comes in front, n log to the base 10 of v. And this looks like y equals to mx plus c. So when they plot log d is the y on the graph against log v, which is the x, you will get a straight line with gradient n and intercept log k to the base 10. So this log d is like your y, it's log v is like your x, and the intercept. So the intercept log k to the base 10, which is the intercept, is minus 1.77. If you follow that blue line there, minus 1.77. So that means 10 to the power minus 1.77, which will give you k to be 0.017. So that is how you can show that that figure, that it can be represented as a straight line. Find a complete equation for the model giving the value of n to 3 significant figures. So we want d is equals to kv to the power n, but v is 30 and d is 20, and we get that from the first graph, and we got k from above, which is 0.17. So we sub in those values. So we sub d is 20, k is 0.017, and v is 30 to the power n. We want to solve it to find n. So we take 0.017 to the left, it becomes divide. So 20 divided by 0.017 is equal to 30 to power n. We take logs, we put logs in front of both of them. Power to the front log, the n comes to the front. So log 20 divided by 0.017 is equals to n log 30. So how do we get n? We divide by log of 30. So n is equals to log 20 divided by 0.017 divided by log 30. And that gives you n to be 2.08. So you can write it as d is equals to k is 0.017 and v with n being 2.08. So that's the complete equation for the model. So you got your d, you got your k, you got your v, and then you got your n, 2.018. Sean is driving this car at 60 kilometers per hour in wet conditions when he notices a large puddle in the road 100 meters ahead. It takes him 0.8 seconds to react before applying the brakes. Use your formula to find out if Sean will be able to stop before reaching the puddle. So 60 kilometers per hour, we want to change it to meters per second. Your calculator can do that for you. But if you're not doing with a calculator, 60 kilometers will be 60 times 1,000 meters to change to meters. Hours is 60 times 60 to change it to seconds. So that gives you 50 over 3 meters per second. You can use your calculator to change directly to that. Using the formula, distance is speed times time. So we know the speed is 50 over 3 and the time is 0.8. That will give you 13.3 meters. 13.3 recurring. Now we got from before d is 0.017 times. We substitute the 60 there to the power 2.08. That gives you 84.92 meters. So we want to find the total stopping distance. So it's that 13.33 meters plus the 84.92 meters. That gives you 98.25 meters as a total stopping distance. But that is smaller than 100. That's smaller than 100. So Sean will be able to stop before reaching the puddle because the puddle is 100 meters away and they only need 98.25 meters before to stop. That's question 9. Question 9A and 9B. And for 9B, remember the 30 came from those numbers, 30 and 20 came from those numbers there. So question 9B and question 9C. Question number 10. Figure 7 shows a sketch of triangle OAB. The point C is such that OC is 2 times OA. The point M is the midpoint of AB. And it says, part A, find CM in terms of A and B. So this is the diagram of what it looks like, and we want to find CM. CM is the same as CA plus AM. So CM is the same as CA plus AM. CA plus AM. So, but AM is the same as half AB, half of AB. So now we know what CA is. So OC is 2OA. So OC is 2 times A. So CA is half of CO. So CA is half times minus 2A, which is minus A. So that's why we know CA is minus A and half AB. We know AM is equals to half of AB. But let's find AB. AB is the same as AO plus OB. Repeat, AB is the same as going from A to O and from O to B. So A to O is minus A and O to B is B. So you can swap them around, it becomes B minus A, which is AB. And since we know AB, AM is half of that. So half of AB, which is half of B minus A, is our AM. And that is what we substitute in there for AM. Or we can put it there, half of AB. So minus A plus half of B minus A, which is, that represents AB. So if you remove the bracket, minus A plus half B minus half A. So when you remove the brackets and you simplify it, you got minus A minus half A will give you minus 3 over 2A plus half B. Half times B would be half B. So that's your answer. Minus 3 over 2A plus a half B. For part B, show that ON is 2 minus 3 over 2 lambda A plus a half lambda B, where lambda is a scalar constant. So we want to find ON is OC plus CN. So we can have OC plus lambda CM. So we know CM is minus 3 over 2A plus half B, and we know OC is 2A. And we collect the like terms, 2 minus 3 over 2 lambda A plus 1 over 2 lambda B. So we collect by factorizing. We collect the ones with A together and the ones with B together. So this would be 2 minus 3 over 2 lambda A plus 1 over 2 lambda B. That's what ON is. So remember from the diagram, ON, to go from O to N, is going from O to C and then from C to N. So O to N is the same as O to C plus C to N. And then for part C, if you notice O to N and N to B, they're all on this straight line there. O to N and N to B, they're all related to this B. There is no A in it. So the A part is 0. They only have O to N and N to B. That's what the idea we use for part C. For part C, it says prove that O to N is to NB is 2:1. The coefficient of A is 0. So we want to find the value of lambda because there is no A on ON. OA is 0. So we want to put all of this to be 0. 2 minus 3 lambda equals to 0. So that gives you lambda to be 4 over 3. Now that you know what lambda is, so ON would be equals to 0 plus half times lambda is 4 over 3b. Half times 4 over 3, it gives you 2 over 3b. So that means NB would be 1 over 3. Because if ON is 2 over 3, what do you add to 2 over 3 to get 1? You get 1 over 3. So you can look at it this way. ON is 2 over 3b. NB would be 1 over 3b. So 2 over 3 is to 1 over 3. The b's will cancel out. 2 over 3 is to 1 over 3. If you times 3, this will end with 2, and this will end with 1. So you end up with 2 is to 1. That's question 10. Question 10A and part of B. question 10C, and the rest of question 10. Question number 11. Figure 8 shows a sketch of the curve C with equation y equals to x to the power x. Find by first taking logarithms the x coordinate of the turning point of C. So we have y equals to x to the power x. We put ln natural log in front, so it becomes ln y is equals to ln x to the power x. The x comes to the front, power to the front law. So we got ln y is equals to x ln x times ln x. How to differentiate x times ln x? We use product rule. That's the formula for product rule. So u is x and v is ln x. Using product rule, that will give us ln x times 1 plus x times 1 over x. And differentiating ln y will give you 1 over y dy over dx. When you differentiate ln x, you get, if y equals to ln x, dy over dx is 1 over x. But this is ln y. So you get 1 over y, and then you times by dy over dx. Now you have 1 over y dy over dx is equals to ln x. The x will cancel, ln x plus 1. So the next thing we said, dy over dx is equals to 0. So that means if you have y equals to, you take the y to the other side, y equals to ln x plus 1 equals to 0. So either y equals to 0 or ln x plus 1 equals to 0. So ln x will be equals to minus 1. Ln is the same as log to the base e. So ln is the same as log to the base e. Log to the x to the base e is equals to minus 1. So this is like e to the minus 1 is equals to x. So e to the minus 1 is, if you put e to the minus 1 on your calculator, you get 0.367. And if you plot the graph, you find dy over dx equals to 0 for the minimum point, you will get the same answer. That's a way to check your answer. So you can use the calculator to check your answer is correct, e to the minus 1. The point P, alpha 2 lies on C. Show that 1.5 less than alpha less than 1.6. So we want to sub in x equals to 1.5. So put 1.5 there and 1.5 there. So we're replacing x with 1.5, and that will give us 1.83. We replace x with 1.6. Replace x with 1.6, and that'll give us 2.12. So that means when you have 1.5, you get y to 1.8. When you have 1.6, you get y to be 2.1. So the curve C contains the points 1.5, 1.8, and the point 1.6, 2.1 at y equals to 2. And since C is continuous, 1.5 is less than alpha, less than 1.6. Question 11C. Find x to the 4 to 3 decimal places. Describe the long-term behavior of xn. So we are using this iteration formula there, iterative formula. So n is 1, so it'll be x1 plus 1, and it's equals to x1, so put 1 for n and put 1 there. So 2x1 to the power 1 minus 1. And we know x1 is 1.5, so 1.5 comes there and 1.5 comes there. So that'll give us 2 times 1.5 to the power 1 minus 1.5. And you get the first one as 1.633. The next one, when n is 2, so it'll be 2 plus 1, that'll give you 3. So it'll be 2, x2, and x2. So we will substitute 2 times x2 to the power 1 minus x2, and that'll give us 1.466. And that would be x3, 1.466. And you substitute n equals to 3. So it'll be 3 plus 1, it gives you 4. And that will be x cubed, x3 to the power 1 minus x3. So 1.446 times 2 to the power 1 minus 1.446. And that gives you 1.673. So you use your calculator to do all of this. So your four answers will be x1 is 1.5, x2 1.633, x3 1.466, x4 1.673. And you can see when you're using your calculator, you can just press answer and use answer. That would use this answer there, and we'll use that answer there to give you this new one. So that's what will happen. So you use the answer there and use the answer there to give you this one. So you don't have to type the numbers all over again. And you can see here you get 1.466, and for the last one you get 1.673. Part D, describe the long-term behavior of xn. The long-term behavior, we know xn oscillates, is periodic, is non-convergent, and is between 1 and 2. Or a periodic sequence with period 2 oscillates between 1 and 2. You have x1, x2, x3. So x1 is 1.5, x2 1.6, x3 1.4. So it goes 1.5 to 1.6, comes to 1.4, goes to 1.6, comes to 1.4, goes to 1.7. So you can see it's oscillating, and it's periodic, and it's between 1 and 2. And if you plot the graph of y equals to x to the power x and the line y equals to 2, you see where they meet at 1.559, and that line where y is 2. So that's where they meet. So that helps you for your answer for question 11b, to check your answer for question 11b. So that's question 11. Question 11a, question 11b, question 11c, question 11d, and the rest of 11d. And this is how to check your answer for question 11b using the calculator. Question number 12. Prove that cos theta over sin theta plus sin 3 theta over cos theta equals to 2 cot 2 theta. So for question number 12a, we want to change the left-hand side to equal to the right-hand side. So we start by adding the left-hand side. We take the lowest common multiple. The lowest common multiple is sin theta cos theta. So when you divide sin theta cos theta divided by sin theta, you're left with cos theta and cos 3 theta there. And you do the same, you have sin 3 theta and sin theta. So the numerator, we can write it as cos 3 theta minus theta. If you remember cos A minus B, if you use cos A minus B, so that's like your A and that's your B. So we write all of that as cos A minus B. But 3 theta minus theta, what's 3 minus 1? Is 2. That gives you 2 theta. So it's cos 2 theta over sin theta cos theta. And if you remember, sin 2 theta is 2 sin theta cos theta. And if we take the 2 to that side, it becomes a half. So half sin 2 theta is equals to sin theta cos theta. So we replace sin theta cos theta with a half sin 2 theta. Now sin 2 cos 2 theta divided by sin 2 theta, it gives you cot 2 theta. And 1 divided by a half, it gives you 2. So you get 2 cot 2 theta. 12b, hence solve between 90 degrees and 180 degrees. That equation equals to 4, giving your solutions to 1 decimal place. Now, we have shown before that all of this on the left-hand side we can change it to 2 cot 2 theta. So instead of using the one on the left hand side, we replace it with 2 cot 2 theta. So we're going to have 2 cot 2 theta is equals to 4. That's what we want to solve. We have replaced that with 2 cot 2 theta. Now cot 2 theta is the same as 1 over tan 2 theta. And we take the tan 2 theta to the right hand side. It becomes 4 times tan 2 theta is equals to 2. And we take 4 to the left hand side, it becomes divided by 4. So tan 2 theta is equals to a half. 2 divided by 4 is a half. So 2 theta is inverse tangent of a half. When you get inverse tangent of a half, you get 26.565 degrees. But tangent repeats every 180 degrees. So you add 180 plus 26.565, it gives you 206. And you add another 180, it gives you 386. That means you add 180 the first time, and then you get 206, and you add 180 to that 206, you get 386. But now we want to get 2, that was 2 theta. We want to get theta, so you divide by 2. So 26.565 divided by 2 gives you 13.2. And then 206.5 divided by 2 gives you 103.2. And 386.5 divided by 2 gives you 193.2. But they want the answer between 90 and 180 degrees. Very important. They want the answer between 90 and 180. So 13.2 is small, is below 90. And 193 is above 180. So the only one we want is 103.28, which we can round as 103.3 to 1 decimal place. Now, for those who use the graphics calculator, this is how you can check your answer. And sometimes when I mark the exams, some students use this graphics calculator and get the answer and write it down. They don't show the working. They wouldn't give you a full mark. You wouldn't get mark for it, but you need to show the working. But the graphics calculator is there to help you to check your answer. So if you put that equation on the left-hand side, cos 3x over sine x plus sine 3x over cos x, that's the left-hand side, the y1. And you put y equals to 4, the right-hand side. So you got the left-hand side for the first graph, the right-hand side for the second graph. And you want to find where they meet, where the right-hand side and the left-hand side meet. In the graphics calculator, the right-hand side is the red line, y equals to 4. The left-hand side is the blue curve. They meet at this point there. And what is the point for x there? X is 103.2, which you can round to 103.3 degrees. So that is your answer. The calculator gives you your answer. And you can put the view window to 90 to 180 for x and for minus 10 to 10, so you can see clearly. So you can see your answer clearly here, but now you need to show the working so that the examiners know you know what you're doing. And you can still sketch this graph at the end. There's no harm in it, but the important thing is to make sure you show the working. So that's question 12. That's how to use the graphics calculator to find out the answer. That's the answer to question 12A. The first part to question 12B. And the final answer to question 12B. Question number 13. A manufacturer produces a storage tank. The tank is modeled in the shape of a hollow circular cylinder closed at one end with a hemispherical shell at the other end as shown in figure 9. Part A. Show that according to the model, the surface area of the tank in meters squared is given by that expression there. So we need to get the area of a sphere, area of a cylinder, area of a circle. Those are very important formulae to remember. So volume of hemisphere plus volume of cylinder is equals to 6. So volume of hemisphere is half of the volume of a sphere. So that's why we times by half of the volume of a sphere. plus volume of cylinder. Now we have this expression. We make h the subject. So we want to make h the subject. So we take 2 over 3 pi r cubed to the left. It becomes minus 2 over 3 pi r cubed is equals to pi r squared h. So since pi r squared h is equals to that, we want to divide by pi r squared. So 6 divided by pi r squared is equals to 2 over 3 pi r cubed divided by pi r squared. You notice on this side, the pi and the pi will cancel. R squared divided by r cubed divided by r squared, it will cancel and you're left with just r. So your h is 6 over pi r squared minus 2r over 3. Now we want to write the total surface area. The surface area is the area of the circle, pi r squared, plus the area of the cylinder, 2 pi radius times h, plus the surface area of this, the hemisphere, which is 2 pi r squared. So what you want to do is to divide by 10 pi and find the cube root. So the cube root of 36 over 10 pi will give you 1.046 and the radius would be 1.05. For 13C, calculate the minimum surface area of the tank, giving your answer to the nearest integer. So we have the formula for area, A minimum. So we had that radius 1.046. We sub that in, sub in the value for the radius, and sub the value for the radius there. Put that in the calculator, you get 17.20, which is, will give you to the nearest integer, it gives you 17 meters squared. And if you were to plot the function on the graphics calculator, and you look for dy over dx equals to 0, the minimum point, you will get 17.20, which is the same like that. And to the nearest integer, that will be 17. So that's where you can use your calculator there to check if your answer is correct. And that's the setting you will use for the calculator. For the view window, x will go from minus 10 to 10, and y will go from minus 50 to 50. And you enter the function, and you get the graph. And then you go to GSolve, look for minimum, and that gives you 17. That's question number 13. 13A and the second part of 13A. 13A and part of 13B. And 13C. And how to plot the graph on the graphics calculator for 13C.